Hello students and welcome to my YouTube channel 4stra. In this video we are going to solve AP Physics 1 free response questions that is being asked in 2025. So let's begin. A block of mass capital M is released from the rest at position x is equal to 0 near the top of the ramp. The ramp makes an angle theta with the horizontal. The block slides down the ramp with negligible friction at x is equal to 8d. The block makes with the contact with an uncompressed spring. So the spring is at 8d with spring constant k. The spring is then compressed and block momentarily comes to rest at x is equal to 12d. So the velocity of the block is 0 when the full compression would be there, or x max would be there. So x max in this case, or the amplitude in this case, is 12d minus 8d, which is 4d in this case. A part. Figure A shows the energy bar chart, represents the kinetic energy K of the block, the gravitational potential energy Ug of the block spring earth system, the spring potential energy Us of the block spring earth system at the instant that the block is at 10d. So when the block is at 10d, it is shown in this figure. Okay. So the gravitational potential energy Ug of the spring block spring earth system is defined to be 0 when the block is momentarily come to rest at x is equal to 0. X is equal to 12d. So x is equal to 12d is this position where the Ug is equal to 0, or we can take it as a reference height. So h at this point is equal to 0. We are taking it as a reference height, which is 0 for this case. Ug is 0 at this point. Draw the shaded bar graph for represent K, Ug and Us when the block is released at x is equal to 0 and x is equal to 6d. So when x is equal to 0 means this is the position of the block and the velocity is 0. So the kinetic energy in this case would be 0 and the spring is not compressed. So the Us would be 0 and there would be potential energy. And how much potential energy? So it is the potential energy at point x is equal to 0, which would be converted to kinetic energy, potential energy and the spring energy. So the total of this, so it is 7e naught, and this is 2e naught, and this is 3e naught. So the sum of all this is 12e naught. So this is the energy, potential energy at this point. Rest is 0. So K is 0 and spring potential energy is 0. Only the 12e naught. So this is the graph. This is the bar graph for potential energy of the spring block and the system at x is equal to 0. Let's see the graph for x is equal to 6d. So at 6d, the block and spring is not in contact. So the potential energy of the spring would be 0. But at this point, some of the potential energy which is at x is equal to 0, it would be converted to kinetic energy. And as you can see, so this is the base line where the potential is 0, and this height, at this height, the potential energy is equal to 12e naught. So I can write that 12e naught, this is the total energy at x is equal to 0. So this was at height something at if I say mgh, h is this height, so it would, this height would be h upon, and this hypotenuse is 12d because the 12 at 12 level it is 0. So it would be 12 is equal to sine theta. So h is equal to 12 sine theta. Okay, and for this height, this is h2, let us say. So h2 would be equal to, so this hypotenuse is now 12d minus 6d. So it is now 6 only. Instead of 12d, now it is 6d only into sine theta. So just half of it. If you see, it is just half of it. Means the energy, potential energy and the kinetic energy. So it would be converted to these energies only. Spring is 0. So that's why this potential energy would be half of it, half of the initial what it has at x is equal to 0. So it would be 6e, and the rest would be converted to kinetic energy. So this would also be 6E naught only. So it would be 6 naught and 6 naught, 6E naught and 6E naught. And this would be 0. Let's solve B part, which says in figure 5 shows the block at x is equal to 0 when the block is released from the rest, and the block at x is equal to 12D. Okay. When the block momentarily stops at rest against the compressor spring. Stating your conservation of energy, drive an equation for the spring constant K. Express your answer in terms of M, and this is not I, this is actually theta. Theta, D, capital D, and physical constant as appropriate. Begin your derivation with writing fundamental physics principle. So what would be the principle applying at this position and this position? So it would be conservation of energy. So I can write conservation of mechanical energy, and the energy at this point it would be E naught, or instead to avoid this confusion, so it would be EI. I can write, and at this point it would be EF. Okay, EF means at x is equal to 12D, and EI is x is equal to 0. So the mechanical energy, or I just write a general term, it would be the combination of kinetic energy plus the potential energy between the spring block and earth system, and the elastic potential energy of the spring, so US. So at this point K plus UG plus US is there, and this would be 0, and only the potential energy is there, and this is the base where from where we are measuring everything, and this is the reference point, and I am considering H is equal to 0 at this point 12D. So to find this height would be equal to, just we derived it, so it would be 12D into sine theta. So the potential energy at this point would be equal to mgh. H it would be 12D into sine theta. And this is the final mechanical energy at x is equal to 12D. This would also be K plus UG plus US. At this point, because it is at momentarily rest, so kinetic energy would be 0, and it is at 12D. So the H at this point is 0, or I can write that H UG, the potential energy, would be 0 at this point. Only the elastic potential energy of the spring would be there, and this is equal to half K x square. X is the displacement, so I can write in this case that EF is equal to half K, and how much displacement has happened, like initially it was at 8D, and the displacement has happened because it is fully compressed, so it is 4D, the square of it. So under the conservation of mechanical energy, I can write that mechanical energy initial is equal to the mechanical energy final, or I can write mg 12D into sine theta is equal to half K 4D square of it. So when you solve it, I am solving it here. So mg into 12D upon into sine theta upon twice of it, and it would be 16D square is equal to K. So this is a K term, and when you solve it, so it would be 8, and 8 would get cancelled, so it would be 3, and it would be 2. So, and D would also get cancelled. So the term I get is 3 upon 2 mg sine theta upon D. This is my K term. This is the K term I am getting. Figure 6 shows a graph of energy of the system as a function of position of the block from x is equal to 8D to x is equal to 12D. The spring potential energy US of the spring earth system is shown in the figure. On the axis shown in figure 6, do the following. Sketch and label a line or a curve that represent the total mechanical energy for the block spring earth system as a function of position of block from x is equal to 8D to x is equal to 12D. So from this point to this point, we have to show the total energy. So the total mechanical energy is the sum of kinetic energy plus potential energy plus elastic potential energy of the spring. So this is equal to 12 E naught, as we have seen in this graph also. So it was 12 E naught. So we can just draw a straight horizontal line on 12 E naught representing the total mechanical energy from 8D to 12D. So the energy is converting from kinetic to elastic, but there is no change in the total mechanical energy. It would be constant, it would be conserved. So it is a straight line. So this is for the first part. And for the second part, sketch and label a line or curve that represent the gravitational potential energy UG for the block spring earth system as a function of position from x is equal to 8d to 12x is equal to 12d. So at this point 8D, the block is at this position. And this is the position where the block and the spring just touching each other and there is no compression in the spring. So the energy which the block has is the kinetic energy plus the potential gravitational potential energy. So I can write that at this point the potential energy is equal to mgh3 and this h3 is this height h3. And from this, when it is at x is equal to 0, the potential energy is equal to 12 V naught, or I can write this is was equal to mg, and from this height h1, this is height h1. So h1 height is 12d sine theta, 12d sine theta. So this E naught is basically mgd sine theta into 12. So this is E naught. So now I can substitute H3 value. It would be mg. So this hypotenuse is 4d, 4d sine theta. So again replacing mgd sine theta as E naught. So it would become 4 E naught. So gravitational potential energy at point x is equal to 8d is equal to 4 E naught. UG at x is equal to 8d is equal to 4 E naught. So this is the point. At x is equal to 12, the kinetic energy is 0 because it is at momentarily stop. So the potential energy at this point, gravitational potential energy, because it would be 0 because it is chosen as the reference line. So h is equal to 0 at 12d is assumed. So it would be just connected with the straight line. So it would be a straight line. It would be something at this point passing through this point. Let's see the point D. Indicate whether the speed at 9D of the block at x is equal to 9D is greater than or less than or equal to the speed at 8D of the block at x is equal to 8D. So this point is 8D and this point is 9D. When the block is at 8D, its potential gravitational potential energy would be converted to kinetic energy, increase the kinetic energy plus the compressing the spring, or it would be converted to elastic potential energy of the spring. So from 8d to 9d the velocity would increase as well as the spring would get compressed. So that's why the velocity at 9d would be greater than the velocity at 8d. So justify your response consistent with the energy curves or curves you drew in figure 6. Okay, so in figure 6 from 8 to 90, if you see the spring potential energy at point 8D is 0, US is 0 in this case, UG is equal to 4E and the kinetic energy at this point would be equal because total is 12E naught and 4E naught is the gravitational potential energy. So 8E naught is the kinetic energy at this point. And at position x is equal to 9d, us this is not at 1 E naught, it is somewhat less than, just less than 1 E naught. And because this line is a straight line and it would pass through this point, it would be a straight line when you draw with the scale, so it would be passing through these points. So the ug in this case would be equal to 3 times of E naught. So I can write that the total energy, total mechanical energy 12 E naught is equal to kinetic energy plus potential energy plus potential energy of the spring plus gravitational potential energy. So I can write that it would be 3 naught 12 E naught minus 3 E naught, and it would be less than E naught, somewhat less than E naught, and minus E naught, but not complete E naught, but less than this. So that would be equal to kinetic energy. So kinetic energy would be 8.12 something. There would be some value into E naught. So this kinetic energy, if you see, it is 8 E naught in the first case, 8D, and at 9D, it is somewhat kinetic energy is somewhat greater than 8 E naught. So that is the explanation for this. Thank you for watching. Like the video and comment about this question, how you solved it, whether you did it correct or not. And if you have any query, you can WhatsApp me using this scanner or send me an email on forso.physics@gmail.com. See you in the next video.